So, a little bit about where I come from and me. I come from a company called Novotek. We are working the northern part of Europe, UK, and actually now also Switzerland. We are a preferred distributor for a lot of world-leading suppliers like GE Digital, PTC, and Kepware. And since this is OPC, you probably a lot of us are using Kepware in different applications. We have been doing this for like 35 years in the OT environment. Myself, I've been working with this for more than 25 years, ranging from everything in the OT and industrial communication area, except PLC programming. So basically, from SCADA and communication up to industrial IoT applications. So that's a short introduction of me. I will take a little bit of introduction of what we have learned when we have built applications and helped customers, and this is both smaller customers but also enterprise customers, in when they start using these OPC data, especially when they are starting using this in their digitalization initiatives. So basically, if everything is good, there are physical equipment locally on each and every on many places on the site. They have their OPC UA server, hopefully. It could of course be legacy, so we need to convert that to OPC UA with different tools. But basically, they have all the information about the physical equipment. That information is used for by different applications, like normal SCADA MES solutions. But now, coming from the cloud initiatives, comes IoT edge devices that is natively knows OPC UA. So that is coming now. I heard now, I didn't know about that Google has joined the OPC Foundation. So we'll probably see something from there also. And of course, ERP systems that can also use that. But then, this is the digitalization for, let's say, the last 3, 4, perhaps 5 years, coming cloud, and that has, of course, accelerated now. And with the pandemic situation, we are that has increased quite a lot. So we see that. But there we introduce some sort of a little problem. I will go deeper into that because the local handling is that the physical, on the lowest level, we have objects. And then we tend, and especially with the legacy equipment, tend to convert that to individual tags. And then when we want to use that information in the cloud, it's much preferable if we can get those in objects, because the cloud is of course developed by programmers that knows object-oriented programming, etc. So we need to rebuild the objects in some way. So we have seen several customers that starts to publish and send out tag-based information. So that means that there is a whole pile of tags, basically. So that's the main why we want to model, because we're talking a little bit, we've heard here both from Neste and from OPC Foundation that we want to model things. Why do we want that? For those who are not that aware of what cloud does, is that when we do modeling, we can do automatic setup of application. We can do automatic testing because we generate the setup, then the testing becomes much easier. This also gets us into scalability, of course, because that's the key thing about cloud, about software in general. That's the possibility to instantiate hundreds or thousands of objects. And that's not particularly what we are used to. We've been working for many years in the OT environment, because we that are a bit older, we come from the old ladder programmed PLCs or register-based PLCs, and they were not that object-oriented. But also it becomes much more manageable, so that you can actually monitor these and see if everything is working when you run it 24/7. So that's what we have seen there. So I'll take a little cloud streaming example around this topic. This is a typical way that customer that starts a pilot or POC with cloud initiatives
they have hopefully a OPC UA server. They're becoming more and more popular now. We see that, and that's good. I personally have been around since the OPC Classic started up, and I really like it. So we have the machine OPC UA to HMI. Then we have something, because when you come to cloud, there are some other protocols. It's I think it's really good that the industry is working with the goal to have OPC as a standard, but you have to realize that today MQTT is the dominant way of transmitting information in the cloud. So normally you have your tags, you send them via, for example, MQTT gateway, typical document like this, JSON document, where you see the timestamp for the document, ID, that's pretty much the tag name, value, quality, timestamp for this sample. So this is what's streamed up to the cloud, individual things. So what's the problem with those tag name streams? It's basically that we have seen, first of all, industrial raw data. We heard here from Ines, they were talking about 80K tags from a site. That can, of course, cost a lot. That has gone down, especially storage has gone down, but ingestion still can cost quite a lot in the cloud. When you do those individual tag-based handling and don't have a model, the ID tag name is often the only thing to bind them together, to find the objects again. And then you have timestamp that is not aligned on tags, different poll time, different compression, dead bands. You still do subscription-based or poll-based handling of getting the data in. And I can say that I've had a lot of customers that has IoT initiatives that take the raw data streams, and in the cloud, they put a lot of effort to be able to aggregate those raw data streams to 10-second values or 5-second values in traditional SQL tables like Azure SQL or similar things, because that is what they need when they do analytics. But you can, of course, do metadata catalogs and things like that in the cloud quite direct today. But we have seen that is often scripted / programmed. It's not so OT friendly because it comes from the programming world, from the IT world. It's not so OT friendly. But we also know that the OT team, the local team, they have the knowledge about the data and the machines. So they need to be involved in some way. And that is something we have seen, that the communication between those two, to be really efficient in your digitalization, it needs to be a good communication between these fields, because they have different knowledge and expertise that can benefit from each other. And we tend to end up with like digital translators. So that's something we have seen. Do it a little bit deeper is that basically what we see is that if you have, we have been discussing a little bit about OPC UA information modeling. That is standard. I think that it will be good, but on the other hand, we have 20 years of legacy equipment, and it takes time to adopt. But the customers and the companies, they want to act now. And that means that one of the ways is to define the models themselves, and the other way is to try to do something now. So that's something also we have seen. We have, for example, here on the OT level, let's say a Siemens equipment and an ABB equipment. They publish things. If they do tag-based publishing, they publish different namespaces and with metadata. And this requires quite a lot of custom scripts. And that's normally the first step you do when you have a POC pilot. You do custom scripting to decode this. You call up the local OT team and you discuss with them and you see, okay, this is how this machine works. This is where you get the tags. This is the tag name standard you are using here. You do script functions. Either you do it when you ingest or you do it in your application. So different approaches there. But this was just
2 namespaces. A normal factory has 10 to 30 namespaces. Even the large DCS-based factories like the dense process industry have quite a lot of namespaces if you look in under the hood, because there is different namespaces for they might have 2 different DCS systems. They do have a QCS system for the paper web. They do have some packaging, rolling machines, water wastewater solution, energy boiler to get the steam. And it might be that all of them have different namespaces. And if you take more traditional industries that buys machinery, ready machinery, then every machinery pretty much have a different namespace. So the big challenge is, how do you scale this? You can build a pilot POC, and how do you scale this out when you have more plants, or up with new smart applications? So this is basically this. You scale out plants, but you also scale out applications. And when you say applications, what we see quite a lot is that third-party suppliers, could be startups, could be vendors of heavy machinery, they have really smart things, but they need the data. So how do you do that if you haven't worked with your data in a good way so that you have it structured? That means that it becomes a lot of custom script. We have seen that a simple example is that just the EGU unit, that is a good one to get with the data coming up to the cloud, because then suddenly you realize what it is. It's kilowatt or kilowatt hours. So then you can start working with the data. But that is the main thing, the industrial IoT, IT, third party. What we have seen, the initiatives come driven a little bit more from the IT side. They don't know the local OT structure. This means that it's costly and long lead time to scale. It takes, in a matter of perhaps weeks, sometimes months, to add a new robot, conveyor or a motor or something like that, because they do not sit on the same place. Many times similar scripts are developed, and what we also see in custom scripts, they are hard to monitor and maintain for 24/7 operations. So suddenly the analytics model is not trained because the ingestion has stopped for some reason, or the decoding has stopped. And then it's a lot of work to get it back. So they are not that robust yet, because OT has a lot of experience in building robust applications. That's where we introduce sort of, not we, the data ops term is something introduced by IBM. It's the orchestration of people, processes, and technology to deliver trusted business-ready data to users, operations, applications, and AI intelligence solutions fast. That is the key. The key word there, I think, is fast, so that you can actually start leveraging all this type of smart applications. So how does that see? I would say often missed link for. We have seen that the companies that actually work with this really well, they have in our world, and I know that's backed by some research institutes, that they have better success rate when they do. We had a good example. It seems like a good example. I don't know Neste, but they have seem to have worked with this type of modeling quite a lot. And that means, for example, producers, consumers for data contracts, the governance of the life cycle of the data, the correlation, connection between the data definitions, and that ends up with the information and system architecture. You have the people working on it, and there's a lot of people involved. There is some of them mentioned here: data engineers, information architects, system architects, that needs to handle this. And then, of course, one small part of it, the technology that supports this: edge handling, integration hubs, trying to get a unified namespace. I sometimes refer to create a common DCS system of the complete enterprise, because that is, a DCS is the object-oriented way of doing process industry.
And of course, trying to leverage as much open standards as possible. OpenSea is definitely one of the leading standards there, but there are other standards also coming in this area. The data ops solution, when you take that in, we had one example earlier on the presentation here. The possibility to standardize and contextualize information models and manage the information flows so that you are in control what flows goes where. And that is also that there could be a lot of consumers of the same data. That's the pub/sub handling. It should be designed for OT. And that's one thing that we have seen, is that it should be possible for OT to work with this. And that means edge native, on-premise, lightweight, web-based, so that you very easily can access and change things when things change in the factory. System agnostic, work on different types of architecture like Linux, Windows. Codeless interfaces, so that you don't have to maintain code, because that is, OT people are normally not programmers. So that means that you need to provide tools to build this and do that configuration in a non-code way. So this is sort of an example how you could do it. Is basically to use different edge devices that can actually combine this information and send a unified namespace to the data lake. And that means, what I mean with combining is that sometimes if you have, for example, a CNC that has an OpenSea UA server on it, but it also might have an OpenSea DA server that handles the load unload robot, and that might not be integrated fully in the CNC. So that means that already there on the same machine you have two different data sources that you need to combine to provide good data, good quality data to the cloud applications. And what you want to achieve is more of the things that you have a document that actually sends the vital information together, so that the cloud applications, the different, we see how web-based analysis or predictive maintenance, etc., they don't have to do all this combination and custom scripting themselves. So what you gain by doing this, of course, the OT expects to more quickly and securely provide good quality factory data. The main thing is that the OT still owns the data. It's not that the initiatives call, get some data, and then it's over. It should be driven from the OT's part. And it's faster and more secure usage of cloud domain solutions, so that you can actually benefit. If someone says, we have a smart thing for pumps. Okay, we have model pumps. They have a unified namespace. We have 500 of those. You can start using that with just a small integration script, and you can publish that data very easily to that supplier and hopefully get a result back. And of course, smart cloud solutions, they auto-create application. Oh, here is a new pump. We auto-create it in the application, put it in some sort of a quarantine. Someone is releasing it, saying that, okay, this is okay. And suddenly you have one more pump in your application without pretty much any time. So with that, I can leave questions. We save that, I think, because of timing. We are at 13:30. Sorry, I'm in Sweden. So 13:30, and we can save